We're doing our warm-up. Line AB is parallel to line CD. So the diagram, you could draw yourselves two lines. And remember, 2 points define a line. So you have to draw at least 2 points to name it. And then I haven't told y'all this yet, but to show that those really are parallel, you put an arrow in the middle of the line. This line is parallel to this line. That's how you show that two lines are parallel. All right, so for the notation, capital A, capital B with a line on top is parallel to capital C, capital D with a line on top. Good? Makes sense? Segment EF is congruent to segment GH. You could make the segments collinear, or you could make them non-collinear. It's kind of up to you. So segment EF is congruent to segment GH. And if you don't believe me that they're congruent, then I can put a symbol on them to tell you that they are in fact congruent. So if you put a little tick mark and a little tick mark, then now those are congruent, whether you like it or not. And for our notation, EF is congruent to GH. Okay? Remember, it did say segment, so you're not going to put arrows on those. And last one, let's see if you got this one right. Ray IJ is perpendicular to ray IL. Okay. So ray IJ, this is one way to draw it, is perpendicular to ray IL. And the symbol for perpendicular, I bet you know this already. It's to put a little box in the corner, even though mine doesn't look perpendicular. Now that I added the box, it is for sure perpendicular. There's no arguing it anymore, even though I drew it a little slanted. Okay, so to write that, we would do ray IJ, upside down capital letter T, ray IL. Everything looking good there? Okay, let's move on to checking our homework. Here's page 1 of the answers. I will show more answers in a minute. Point, line, plane practice. Remember, you are checking your answers, and then when you find one that you got wrong, you're circling it or highlighting it, because that's what you need to study, are the ones that you get wrong. And those are the ones you need to ask me about. All right, next page of answers. 7, 8, 9, 10, 11, 12. Starting with number 2 from the homework. Use the figure of the right to name the intersection of the planes. Remember, one of our basic postulates is that when two planes intersect, you get a line. They should intersect in exactly one line. So our answer better be in the form of lines. Let's zoom. Zoom a little bit. I don't know if I want to zoom to 200. Okay, so the first one The first one says UXV, UXV. What I do right away when I'm still learning this is with your pencil, make the whole plane. Connect the dots and find out what the entire plane is. That is the top of the prism, UXV. WVS, WVS is the right side of the plane. So it's asking, where does the top intersect the right? Where does it overlap? Where do those two rectangles touch? That's what it's asking. So the answer is capital W, capital V with a line on top. Because when two planes intersect, you get a line. I'm going to do the next one, and then we're going to move on to the next question, okay? TXW, TXW, connect the dots, and then TQU, TQU, connect those three dots and finish off the rectangle. So where is rectangle 1 intersecting rectangle 2? Right here, Texas is the answer to that one. So you're finding where they're overlapping. You're finding where they touch, okay? Next up is number 6. How many planes contain each line and point? All right, ready? EF and point G. Now, when you name a line and then you name a point that's not on that line, you have now named 3 points, correct? Because this one has at least 2 points and this is 1 point. When you have 3 points, you now have a unique plane, as long as they're not collinear. Let me say that again. When you have 3 points, you have a unique plane, unless they're collinear. So I don't even, once I know that they're not collinear, my answer is 1. I don't need to investigate any further. 3 points equals a unique plane. If I said something else, I'm sorry. Plane. Yes, plane. Okay. Line FG and point P. Line FG and point P. Once again, those are not collinear. So there's only one plane that goes through that line and that point. There is only one. And if you wanted to try to draw it, it could kind of be like that. That is the plane that goes through that line and that point. Okay. Moving on, our next question was 9, B, and C. Let's look at number 9 together. B and C. 2 lines that are skew to EJ. There's EJ. Now remember, when you're looking for skew lines, you want it to never, ever, ever intersect EJ, but it can't be parallel. It can't be coplanar. It needs to be in a different plane. So there's lots of lines we could name that are skewed to EJ. CI, L, I don't even know what that last letter is. It got cut off. LH, AB, FG, BI. Okay, so I think that's most of them. Then you could go crazy and you could shoot through the figure. CB would be skew to JE. So there's lots of different options for 9B. Okay? 9C. This one is interesting because we haven't talked about this very often, about when a line is parallel to a plane. We talk about planes being parallel to planes or lines being parallel to lines, but this one asks all lines that are parallel to plane GFAE. Let's remember what parallel means. Parallel means that they are coplanar and they do not intersect. So I need to find lines that are not going to intersect GFAE. Lines that will never ever, if you extend that figure and you keep going, that they will never intersect GFAE. So I found one that will never intersect it right here. This one will never intersect the red one. This one will never intersect the red one. This one will never intersect the red one. Now, because of how it's tilting, look at like CI. Look at CI. Right now, CI is not intersecting GFAE. But do you agree that if they kept going, eventually they would meet because it's tilted like that? So you have to find ones that would never, ever, ever touch it, no matter how far you extend the figure. Okay? We are moving right along. 11, E, F, G, H. Okay. So 11 was tough. Was 11 tough? Okay. 11. G, E, F, G, H. Always, sometimes, never. We love always, sometimes, never. Wait a minute, there's no picture. So you have to draw your own picture. Imagine that. Okay. Ray, G, H. Okay, Ray, G, H. And Ray, H, G. I'm just redrawing it so you can see. Are always, sometimes, or never the same ray. Do those rays have the same end point? No, they originate at two totally different points. So never ever could they be the same ray. So when you're doing a segment or a line, order does not matter. But when you're naming a ray, order matters. Okay? When you're doing a line or a segment, the order of the letters does not matter. When you're doing a ray, the order completely changes the ray. F. J, K, and J, L are always, sometimes, or never the same ray. Okay. This is when I'm giving you strategies. You just need to start drawing pictures, unless you're good at visualizing this without drawing it. Okay? J, K, and J, L. In this picture, JK and JL are the same ray. Yes. JK and JL, yes, they're the same ray. But then you have to play devil's advocate. And you have to be like, Okay, sorry. Finishing up on F. I could draw it this way, or I could draw it this way. Here's JL, and I could put K over here. Here's JK. So I found a time when it works, and I found a time when it doesn't work. So that's why that would be a sometimes. Sometimes ray JK and ray JL are the same ray. You found a time when it happened and a time when it didn't happen. Okay, we talked about this one yesterday. Two planes that do not intersect are blank parallel. Now, lines, they have two choices. Lines can be parallel or skew. Parallel or skew if they're not going to intersect. Do planes have those same two choices? Planes can be parallel, we all agree. Can planes be skew? No! They're going to eventually meet up. They're going to eventually hit each other. Oh, we are not talking 4D. Where did that come from? So, two planes that do not intersect always... They're always parallel because they don't have any other choices. No other options. And H. Two lines that lie in parallel planes are blank parallel. Okay? There's my horrible planes. Here's an example of when it does work. Here's an example of when it doesn't work. Are those green arrows lying in parallel planes? Yes. Are they parallel? No. So that's why that one's a sometimes. It really helps to sketch a picture.